all good. So this was a 40-minute presentation, shortened to 20, which is now going to be even more shortened, but I'll do my best. So I'm from Carbon 5. My name is Courtney Hemphill. I'm a tech lead and partner at Carbon 5. This logo looks really familiar, I'm sure. Sort of exchanged for HTML5. We've been around since 2001, but everyone always gives me crap about our logo looking identical to the HTML5 logo, so there you go. So what I'm going to talk to you today about, if I can get these to actually advance. No, I'm not going to get you to advance, no. Okay. Ah, I see what happened. Hang on. This went to the end of my slide. Sorry, folks. All right, we're going to actually try to start from the beginning. Is that better? Yeah, that works. Okay. Seriously going to try to start this talk now. Okay. Courtney Hemphill. Hi. Okay, so the purpose of this talk is really to give some basic understanding. You know, we all use frameworks for animation, tween.js, you know, jQuery, green sockets, whatever you use. It's really to give sort of foundational knowledge of really what's happening under the scenes with animation and the basic math that underlies it. There's a meta purpose to this talk, and it's really just trying to bridge the gap between design and development. So as designers, there's really sort of this barrier to really being able to play around with animations in the actual interfaces where they're going to be represented. And from the development side of things, there's really sort of maybe not a clear understanding of what are some of the principles of animation design and what it might look like to actually implement some of that. So part of what I wanted to get through in this talk was not just the math, but also sort of the principles around design. So way back in the day, Winsor McKay was a designer for Disney, and he was one of the first guys who came up with how to do animations for cartoons. So what he did was him and some of the senior designers would create these keyframes, and then they would bring in sort of the junior grunts to do these in-between frames. So in that scenario, it was artists that were naturally taking the movement and creating these in-between frames. In today's world, we use software, which is obviously underlying with math, to create those in-between frames. So really, you know, why does this matter to us? The reality is humans, we see animation, we see motion very innately, and we can intuit things from motion and animation. So using it in our interfaces allows us to really, without doing a lot of text or a lot of help, guide a user through our interface using motion and animation to trigger sort of perceived affordances to the user face elements. So that word perceived affordance comes from Dan Norman. He wrote a book called The Design of Everyday Things. In it, he talks about this idea of you look at a chair, you sort of know what that object is about. You know, you can sit in it, you know it's stable, you know if you pick it up, maybe it's going to tip forward because of the seat. We sort of afford uses for that chair. Equivalently, we can use things in an interface to signify. For example, if you're filling out a form, you see a green button at the bottom right, we're going to afford or signify that that is going to submit our form. We also now have this idea of, you know, if you see an X in the top right corner of a window, probably that's going to close out the window. So there's certain things in user elements now that we can really use and intuit to signify things. And likewise, motion for us is something that we can use based on just our ability that we've evolved to intuit and to map out things in interfaces. So for example, humans, we have really crap detection at our periphery of color and really of objects in general. But we're very, very good at sensing motion in our peripheral vision. So in user interfaces, being able to use animations in the periphery of our screens, it allows us as humans to sort of both notice that and then to perceive that there might be a use behind that motion. So one example of this, anyone ever seen Pinterest? Yeah? Okay. This is, you know, the scrolling grid. Sorry, I've got to go fast here. And what Pinterest ended up doing was this sort of kind of progressive disclosure. So it's an obnoxiously long scrolling page, but by using a little bit of animation, we sort of are continually finding ourselves drawn to the bottom and seeing that new content is going to be loading. Another example is really in navigation. Using animation, sort of the swiping in, swiping out, the loading of different elements allows us to really have sort of the sensory map of where things are lying on a page. So for example, everybody knows like parallax scrolling and these huge long pages that we have now. It saves us the burden of having to load additional pages and using the back button, but it also can sort of leave us stranded. Using just a tiny bit of animation allows us really to get a much more context about where things lie on the page and how we can navigate back to them. So playing around with this sort of stuff with animations can create really powerful interfaces that can really guide a user without having to give a lot of help. Twitter just patented their pull to refresh interface. This is something where, without a lot of logical help or any sort of text given to a user, we know that we can pull down. It's kind of funny because actually it mimics really a slot machine, you know, this sort of constant refreshing of content, and it's something that we get really triggered and almost addicted to. So using a little bit of animation can go a long way to having our interfaces be much more powerful and intuitive. So there's this underlying math to animations and how we can use them in JavaScript. And it's actually really quite simple. I am absolutely not good at math. I'm probably as good at math as I am at French, which is to say very poor. But just moving pixels around a page, that's one way in which to use math and animation. So for example, if we take this simple function in JavaScript and we take our div here, and we play it. Technically, we're moving something, but this is a really simplistic movement. And really, it's tethered to this idea of location. So it's not very powerful if we want to start messing around with this in a much more, in a bigger, more robust way. What we do need to do is start to think about interpolation. So interpolation is where we take whatever the value is that we want and really place it into this idea of like a percentage complete. So the basics of animation lie in interpolation. And the function is incredibly simple. It's really just the value of the time where you're starting that function, where that function needs to end, and then the percent complete. So it's really, everything is boiling down to this idea of a number between 0 and 1. And the magic of a number between 0 and 1 is that you can apply that to anything. It can be a position, it can be a shape, it can be a color. You can also multiply a number between 0 and 1 against another number between 0 and 1, and you're going to get a number between 0 and 1. So your power really comes in this idea of interpolation. And it's actually a really simple thing to add to the JavaScript function we were just seeing. So this isn't really going to get that much more exciting. We're still just moving this div across the screen. But we now have this idea that we can do this not just with position. We can do it with opacity, or we can do it with color. And what we can additionally do is start to mess around with this in more robust ways. The reality is this function is a linear function. And nothing in our world really is linear, right? Linear math is something that, although it has a place, it really doesn't describe the natural elements in this world. And what we as humans have innately started to recognize is natural movement. So in order to have our interfaces feel a little bit more natural and not so jarring, we need to add these elements of variance, right? So easing functions are what you're going to see used in most of the CSS3 animation frameworks, in most of the tween.js frameworks, and they're really actually pretty simple. What you're doing is, it's effectively the same function. You're starting at some place, you're ending in another place, but the variance, how you're going from there, changes over time. So what easing is, there's a variety of functions you can use to ease, but it's really just plugging in that change in property, right? So that number between 0 and 1 against some float. And this can be a power function, it can be a trigonometry tree function, whatever it is. And then you're really just adding that to your beginning value. So if we look at now the very simplest of really an easing function, which is a power function, same exact formula that we're using, but now we're adding that to a math to the power function, right? So we're getting sort of the Ferrari of animation now, which is zoop. So it's a little more interesting. It still isn't, the most robust animation in the world, but you can imagine you can start to play around with these different functions. So now we get the easing out. This is something you see all over the web, this idea of something that's sort of like scooting in and sliding into place. This is used a lot. It also is adherent to some of the design principles of animation, where when you see something enter your field of view, you sort of expect it to be moving at speed and then coming to a slow stop. So these are things that you can start to play around, both as a designer and a developer. And actually, just out of curiosity here, how many people in this audience are designers? or would think of themselves. Sweet, that's a pretty good amount. Okay, and then everybody else is developers, I'm guessing? Okay, it's like a little bit more developers. But designers, the ability to really use animation in the final interface to go into code and start to play around with things, it can be a really powerful way to really tweak things and to prototype them and to see how users react to them. So this doesn't get very much more complex, but you can use trigonometry. It's very similar to what we were just looking at with a little bit more subtlety to it. So these are the ways in which the devil's in the details, right? Some people might find something jarring. If you change around your function a little bit, it might start to feel a little bit more natural to your users. A couple other functions. I keep talking about this like 0 to 1. You can go beyond 0 to 1, and it's really going to give you that idea of like elasticity, right? So something that's going past its ending place, it's going to be like a rubber band and then snap into place. So it's something that adds sort of like humor and playfulness to an interface. And again, although our function is getting a little bit more complex now, it's still isolated to that one realm. You're still taking the change in time, and you're creating a function from it. There are a ton of functions. Most of them can get more and more complex, and you can find them all either by diving into some of the JavaScript frameworks. So like tween.js has got a ton of functions, and you can just start to look through them. And then you can tweak them around to suit them to your needs. Robert Penner also has a website where it explains in detail a lot of the easing functions, and you can grab the functions from that. And really, you can just start to plug and play. So here we get a little bit more fun. Bounces back. Sort of slow on this computer. And then finally, the one that's really the most entertaining, which is bounce. This is sort of like the blink of animation, but pretty playful. So all of these things, they see sort of simplistic and not all that interesting, but put together and used within an interface, they can create something that is of notable effect. So this is something that one of the developers at Carbon 5 came up with, and it is birds on a wire. And so what he was doing was he was trying to create very organic, natural movement with animation. All of this is done with JavaScript. All of this is done with really simple easing functions. And it's just multiplied across these birds and taking sort of, as you can imagine, the ways in which these different divs are relating to one another, and then triggering really just simple animation functions from them. So there's a couple of these examples on the Carbon 5 GitHub account. If you'd like to play around with them, they're pretty fun. So quickly, before my time is actually already up, so there's a lot of tools that you can use, both as a designer and a developer, to create animation. A lot of them come in the form of software. Traditionally, it's like Adobe, QuickTime, Adobe Edge. Quartz is a big one. Keynote is something that people use a lot in our office. You have total control over the animation, but then how do you hand that off to the developers, right? And how do you make sure that what you wanted is represented well to the developers? Another option, JavaScript. JavaScript is fantastic for animations where you want a ton of control. Either you want to know when something started, when it ends, you want to stop it, you want to rewind it. If you need a lot of control over your animations, or you have things that are tethered to one another, then JavaScript frameworks are probably where you're going to want to start. The thing about frameworks is that they're bloated sometimes. You can lean really heavily on them, and they might be harder to tweak. So if you can start from a place that is much more simplistic and then integrate your frameworks once you know better what you want, you will go a lot farther in both your understanding and your ability to really have ultimate control over the interface. So CSS is actually amazingly powerful and completely robust in terms of the animations that it can do at this point. The tricky thing is it's a little bit limited in terms of the control you have over the things that I was talking about before. So your ability to sort of like match it to other events that are happening on your interface. The one thing that CSS does have are some great libraries that are out there that are in existence that you can really just plug and play with. So as a designer, it's a really fantastic way, if you're familiar with CSS, to start to really use animations. A quick note about performance. There's a lot of talk about this. Given sort of the performance of most computers today, unless you're doing a ton of animation and a lot of sort of tethering to events, performance might not be a huge consideration. But the things that you want to keep in mind is that CSS, particularly transforms, they can harness the use of the GPU over the CPU. And so it's really taking away that reliance on something that might be doing something else in JavaScript. So it's something to keep in mind if you do find your animations getting really overperformant, or underperformant, I should say. The other thing is that the CSS layer doesn't have to redraw anything on the canvas, so that can really help out. But really choosing between CSS versus JavaScript, you should really be thinking about what ultimately you want to do. If you're looking to tether this to events, then you're probably going to want to go with JavaScript. If you're looking to tether, to do really pretty simple animations of maybe a button or a div layer, then CSS is probably going to be fine. So I blew through that really fast. Go forth and animate. These slides will be up, and there's a bunch of references to read up on some of this stuff. The Disney's 12 Basic Principles of Animation. If you're a developer that's interested in animation, this is a fantastic read and pretty fun. And if you're a designer, I would highly recommend sort of playing around with CSS and some of the simpler JavaScript functions to see how you can add some animation to your user interfaces. And that's my fastest presentation ever.